Project 5 deals with locating files. We have the locate command and the find command. The find command searches the hard drive each time. The locate command looks in a database that is built every night. Step 2 has us use the touch command to create an empty file. The touch command can create an empty file, or it can update the timestamp on an existing file. When you boot the computer, touch is used to update the timestamp on a file so you can tell how long the computer has been running. Certain programs that start up or services will use the touch command and update the timestamp. That way you can see how long the application has been running. Now they have us use locate and try to find the new file. No file is found. That is because locate looks in a database that's generated at nighttime. We can update the database with the update DB command. After several minutes, the update DB scans all the files on the hard drive and rebuilds the database. Locate will then instantly find the new file. Next, they show us the find command. If I type find space / space minus name space and then new file, it will search from the root directory through every subfolder for a file called new file. Searching from the root can take some time if you have many files on the hard disk. Next, they say use find space / root space dash name quote new file. In this case, we search from the subfolder root and our results are returned faster. We don't search the entire hard disk. So this is the output you should see when executing these commands. Finish Project 5 on your own. Next, Project 6 deals with removing files and folders. At this point, you probably want to take a snapshot of your virtual machine. So click the Machine menu, take Snapshot, before 4-6. Once the snapshot is complete, you can play with the lab. If you accidentally delete more files or directories than you should, you may revert to the snapshot. The rmdir command I rarely use because it only removes directories that are empty. If a directory has files or folders inside of it, I use the rm -r or -R and F. The R is recursive, delete all files and subfolders within the current directory. The F says don't ask questions about each individual file or directory inside. This could be dangerous if you are using this command because it can wipe out entire directories and including files that you may not want to delete. The lab has you change into the samples directory, and it has you run rmdir on the two directories, to delete and under my samples. The to delete directory was removed on my computer. Under My Samples was not, because in previous videos I put files underneath. Here I will use the rm-rf command to delete Under My Samples without asking any questions. Complete Project 6. So you may want to pause the video, and then we will start on Project 7. Project 7 and 8 deal with permissions. On the midterm and final, you will need to change standard permissions on a file and directory. Let's look at the permissions on a file. The sample1 file looks as follows. I'll paste this into a text editor. And we'll break the permissions up so you can better see it on your screen. The first permission, the read-write dash, is for the owner. The second permission, read, is for the root. And the last permission is for everybody else on the system. So permissions are easy: read, write, or execute. They are done in octal, also by exponents. You have 2 to the second for read. You have 2 to the first for write. And you have 2 to the 0 for execute. Now from math class in high school in exponents, you should have learned that 2 to the second is the same thing as saying 2 times 2, which has a value of 4. 2 to the first is the same thing as 2 by itself, or 2 times 1. So that is a value of 2. And something that's a little bit odd with exponents, 2 to the 0 has a value of 1. So read is equal to 4, write is equal to 2, execute is equal to 1. Using the chmod command, which stands for change the mode section of a file. The mode section is where permissions are stored. chmod typically has 3 numbers that you will put out beside it. One for the owner, one for the group, and everybody else on the system. Also better known as other. If I want the owner to have read and write access to a file, I take the 4 for the value of read, the 2 for the value of write, add them together. I come up with 6. If I want the group to have read only, I would use 4. If I want everybody else on the system not to have access to the file, I would use 0. And then I would specify the file name. If I was doing this on a directory and I wanted all files in the directory to inherit this permission, I would use a -R for recursive and the directory name. So the directory would get 640 and all files would get 640. While doing the lab, you may note that directories typically get the execute bit automatically. If a directory does not have execute right, you cannot open and view the directory. Files, when you create them, typically do not have the execute bit, because they're assuming you're creating a text file, graphic file, or some other type of file that is not a program. That brings us to section 8, where they talk about the umask command. The umask is subtracting or taking permissions away. By default, if you create a file, you get all permissions except execute. If you create a directory, you get all permissions, read, write, and execute. So, if you don't want other people on the system to have access to a folder or file, you could subtract the read, write, and execute bit for other. If you want the owner and group to continue having all rights, you don't subtract anything. So I will put 0, 0, 7. If I have a umask as this, when I create a directory or a file, users will have read, write to files, read, write, execute for directories, because I did not subtract any permission. Other people on the system will have no rights because I subtracted all permissions from that section. Let's look at a file and see what happens if I was to run chmod 123 to the sample1 folder. Now 1 would turn on execute, 2 would turn on write, and 3 should turn on write and execute. This is an odd permission setup, but just to show you how that the numbers work. There's my write, there's my write and execute. Common setups would be 640. The user can change the file. Anybody in the group can read the information. Other people on the system have no access. If this was a program, the correct permission might be 555. That should give read and execute, but no write permission. If it is an application, you don't want the application to be changed. A virus may infect the application if you have write attributes. Let's look at that. Here we see we have RX all the way across for user, group, and other. If a virus was to get into the system and try to infect this file, which we are pretending is an application at this point, it would not have rights to infect the file. There are other ways to use the chmod command. You may use chmod with letters such as O, and then add a permission such as write. And I show this in the example. However, most administrators do not use this method. They use the octal method and the numbers. It is faster and more efficient when you get used to using the 6, 4, or 5, standing for read, write, read only, or read and execute. Please practice 4-8 and 4-7 because you will see this on the midterm and final.